Okay. Hi, everyone. This is Jordi from the Vocdoni project. And today I want to share you what we have been doing towards strengthening democracy and how we use decentralized technologies for creating a voting system that is transparent, verifiable, and much better than the current voting systems, digital voting systems. So first of all, let me put you in context. We are in Catalonia in the 1st of October of 2017. And the Catalan civil society decided that they wanted to vote if they wanted to be part of the Spanish state or they want to form an independent state. So everything pretty normal. In a pacific way, they try to vote. And this happened, basically. Sorry for the images. But what happened is that the Spanish central government sent the military police for stopping people to not let them vote freely. So basically, we have images like this. Basically, the police beating people for voting in a democratic country in the 21st century. This is crazy, and this is not what I learned at school. And yeah, at that point, we thought we need to build some kind of system to allow this to never happen again. So also at the same time, we realized that democracy is at risk back then and nowadays. So we are using obsolete democratic infrastructure. There's a clear declining in trust in the institutions, meaning that people, especially younger generations, participate less and they have less engagement. And there are also more other problems, especially related to technology. One of the first cases we can refer is the Cambridge Analytica case, where we had some private companies that were spreading misinformation and manipulating the public opinion. Then, as I showed you in the later images, in the last images, we saw that a nation state can coerce and intimidate people for not voting. And then there's also a biggest risk, I think, which is the nation states have the monopoly of organizing truly democratic elections. They are the only ones that have the census, and they are the only ones that have the resources for creating a proper election with all the democratic guarantees. So yeah, based on that, we started the Vocdoni project, whose vision is to improve democratic health and promote participatory governance using decentralized and open source technologies. So we wanted to create a system for the bright and the dark times. A digital voting system, because of course we cannot solve all the democracy problems, and we need to focus on one. And we decided that creating a decentralized and censorship-resistant voting system was the thing. So the system should be universally verifiable, meaning that since you cast a vote, since the tally is done, you can verify that your vote has not been altered, and also that the tally was done properly. Then the system, of course, should be anonymous. We must protect voters' privacy and even the organizer privacy. This system should be also flexible, meaning that it meets most of the governance requirements of different organizations and adapts also to any identity system. In an ideal world, we would have shared public identity system, which is shared by everyone, but this is not what's happening. So each state has their own system. Even inside nation states, we have different identification systems. Then the system should also be scalable, meaning that we want to reach nation-state elections, and efficient. Also needs to be affordable, because we cannot make people pay for voting, and someone needs to cover this cost. For this, we wanted to use the economies of scale using a shared infrastructure. This system should also be anti-coercion, ensuring free and fair participation, safeguarding against collusion and external pressures, like the ones that we showed. And it also needs to be neutral and unstoppable. The nature of the election to be able to stop the voting if the things are not going as they want. And for this, we used Ethereum, because we think it's the best community, the best technology, and it has the best security guarantees. So a little bit of the journey, of the timeline. We started in 2017. We forked Zcash because of their privacy guarantees, and basically we were sending Zcash transactions in a form of votes. The problem with that is that the Zcash ecosystem is not programmable enough, and we didn't get the flexibility we wanted. We also developed a native mobile application where you can follow some organizations, vote, and so on, and read some news. But yeah, at that point, you realize that people were not willing to download an application that they just use, for example, 3, 4, 5 times a year. It's not like a social media application. Then we transitioned to an Ethereum virtual machine approach using a proof of authority network where the nodes were distributed among universities, public bodies, and also individuals. And we did this because in 2018 Ethereum was not scalable enough, and we also lacked some of the cryptographic primitives that allowed us to create such a system. This experiment went well, but not that bad. And because of that, in 2019, we decided to switch to a Tendermint-based approach. For those who don't know, Tendermint is the base layer of the Cosmos ecosystem. This technology allows you to just focus on the application layer, so we didn't need to care about the peer-to-peer layer or the consensus layer. So basically, we built a Golang state machine on top of Tendermint that allowed us to have the scalability that we wanted and also to implement our own cryptographic primitive, of course, based on the standards and so on. And we also switched to a web application because in order to make it accessible, the best way is to just have a link that you can put it on a browser, and everyone has a browser nowadays. And in 2024, we reevaluated the Ethereum ecosystem, and thanks to advancements in applied cryptography scalability, we decided to start DaVinci, which is a new and a better version of the protocol that we had built on top of Tendermint. So what's DaVinci? So DaVinci stands for Decentralized Autonomous Vote Integrity Network with Cryptographic Inference. Let me segment this a bit. So it's decentralized and autonomous, because the protocol can run autonomously. So there's no central party or coordinator, and it uses EVM contracts as a coordination layer and a purpose-specific ZK rollup. Then it's also a vote integrity network because there's an incentivized network of the votes cast by the users. And finally, we call that this protocol has a cryptographic inference because the network itself, by mathematical meanings, derive conclusions, so the tally exclusively from cryptographic primitives. And everything is fully backed by zero-knowledge proofs. How it works? OK. So in one point, we have the votes, then the voters, the sequences, and Ethereum. So basically, what happens is an organizer wants to organize an election, so it goes to what we call the process registry. It creates the voting process with all the data the voting process should have. And then there are this network of sequences that are listening to this smart contract. Then they fetch the information, and they store it. All the voting process is stored in a form of a Merkle tree, all the data and so on. And then when the voting window opens, the voters can start voting. Of course, before that, the sequences need to generate an encryption key for the voter. And what they do is to do a multi-party computation for generating this key. Then the key is published, and the voters can start sending the votes. The voters on the client side, they encrypt the votes using homomorphic encryption. They prove their eligibility using also a ZK SNARK circuit, and they authenticate using standard Ethereum signatures. They can override the votes as many times as they need. This is one form of lowering the pressure if they are being coerced. And then when it happens on the sequencer side, let's say we have the vote on the voter side, then the voter can send the vote to any of the sequencers, and then the sequencers, what they do is to verify that the vote is running well, and they can re-encrypt, and then they re-encrypt the votes. That way we remove the receipt from the voter. Then they recursively aggregate these votes, and they update an Ethereum, the Ethereum state root hash that is stored on the Ethereum network. For that specific election. When it happens, when the voting finishes, basically is that they talk to each other, they reconstruct the key, and they compute the results. Then the results also pass through a ZK circuit, and we can be sure that the results were counted correctly. All the information, not the public information, but the cryptographic traces are stored on Ethereum, and then everyone can reproduce the election and check that everything is fine. Then, we have the protocol, but then we need something that is usable for the people. And then we enter to the front end and the voter experience. The voting experience should be something that is easy to use, that should work on any device, and it should be user-centric. Easy to use, I mean, my grandmother should be able to vote, because everyone should be able to vote. It's a democratic process. And I don't expect my grandmother to have a hardware wallet. So we need to find a way to circumvent these technical stoppers. And for example, in the images, you can see that one of the methods that we use, for example, is to just send a QR code with a link and an embedded private key on the code. This is sent by postal mail, and then even if you don't have a mobile phone, you can go to a public station and vote. Then, as I said, it should work on any device, so we just use a browser, and all the UI that we created is super Web2, it's super user-centric. The voter doesn't need to know that he's using blockchain or any kind of this cryptographic technology. How it looks like for the voter. Basically, when you open the link for the voting, you can receive this link by postal mail, by email, by SMS, whatever, and then you see this image. Basically, you have the questions, the title of the process, you can also embed videos, whatever you want. Then you click on identify, and then the authentication is up to the organizer, so we are flexible in that terms. We can use electronic passports, we can integrate databases, we can use even CSV files, and in this case, for example, I'm just using my email and my name. Then we enabled a two-factor authentication mechanism, so I will receive a two-factor code on my email, and then I'll be authenticated. Then I will just select my question, my answer, sorry, and I will be able to see that I'm voting for this, and then I will confirm my vote. The vote will be sent to the network of sequencers, and finally I will get a unique identifier that later I can use for verifying that my vote was not altered and was actually counted. This is the UI for the organizer point of view. We have all the voting processes that we created. We have our member base, the settings, and if you want to create a voting process, we have some templates like, for example, annual general meeting, election, participatory budgeting. We can set the process title. We can even attach a video if you want to have some live video. We can add the description. And then we support any kind of voting method. So we can have single choice, multi-use set the basic configuration, so start time and end time, some extra configuration if you want the results to be hidden until the end, if you want live results, and then you select the census based on some filters that you can apply on the member base. Cool thing about this is that we have been serving real-world organizations since 4 to 5 years ago. Here you have the different verticals. We are serving public administrators like the Barcelona City Hall, also super cool. The images that you saw with the QR codes was for the municipality of Bellpuig that held the first legally binding digital referendum in Spain. We also help a lot unions and professional bodies like the official Industrial Engineer College in Catalonia. We also helping membership associations, political parties, for example, New Belarus, which is the opposition of the Belarus government in exile. We also helping sport clubs and entertainment like the Football Club Barcelona. And then given that we have the protocol and then the UI, of course, we have the integrators part that they can use an SDK and API that we have available for integrating the base technology, the base voting technology on their applications. So I would like to showcase 3 real nice use cases that we had during the past year. The first one was 3 weeks ago, where the teachers in Catalonia, more than 100,000 teachers, were on a strike for saving public education. They wanted better classrooms, less ratio of students per classroom, and they wanted better salaries because, you know, inflation and so on. And basically what happened is that the unions had a meeting with the government and they created some kind of pre-agreement. But then the teachers wanted to decide, to do a referendum about this pre-agreement. We've been talking to them and we set up this voting for them. It was amazing. It lasted for 4 days, and the only thing that they needed to vote, it was just their official teacher email. So basically, they put their email, then they received a two-factor authentication code in their email, and they were able to vote, because we are sure that just one teacher will have just one email. The results were amazing, 61% turnout, more than 6,000 votes cast, and nobody contested the results, because we have all the cryptographic traces. Nobody can say, oh, I voted twice, the results are not correct, and all these kind of things. So, well, as we say, legitimacy at scale without relying on blind trust, like using Google Forms or things like that. Second one, almost 2 months ago, we helped the Belarusian opposition for doing an election where this democratic election could not be safely happened in Belarusian territory because the voters are dispersed, there's a lot of political pressure, people are in exile, and there were like a lot of attempts to disrupt participations. It was crazy because I think that the infrastructure was basically attacked by the nation state because we had a big DDoS attack. We went down, not the protocol, but the front end and the API that we are using. We went down for 20 minutes, but well, hopefully we went able to recover. And also the nice thing about this is that the voters used a Belarusian self-sovereign identity that was created by them for authenticating themselves. So in that case, I think that must work when the democracy itself is attacked. And the third one, which is also pretty amazing, we have a political party in Spain called Esquerra Republicana, which basically had some key votes for investing, which today is the president of the Generalitat of Catalonia, which is the government of Catalonia, and they wanted to let their member base decide if they wanted so. So basically, they set up a referendum for investing or not the current president of Catalonia, and this indirectly supported the continuity of the Spanish prime minister. So it was an internal democracy with real political power that required verifiable legitimacy. It was super nice because we had almost 80% of turnout, and there were 20 parliamentary positions at stake. So as you can see, we can leverage Web3 technology. We can create this kind of sanctuary technology, but what we need to do is to make it available to the people. Even sometimes, of course, there's some trade-off. We don't have hardware wallets, but well, if we can create a system that is better than the system that we have now, why not doing so? At some point, we will get there. And that's it. Dankeschön. Thank you for having me here.
All right. Do we have any questions for Jody? We'll be able to take just one question. Yes, just in front.
Thank you. Amazing. I'm not sure if I did understand.
What we have is a thing called the valid protocol, which is basically a way of expressing the way you interpret the results of an election, which is basically a matrix where you will be able to say, for example, for this specific voting, the results needs to be counted like this. And this is fully supported. So it's just a matrix, it's super extensible, and we support any kind of voting you can imagine. Thank you.
All right, let's put our hands together for Jody. Thank you.